Chapter 16, Chemical Equilibrium. And this is a quote from Henri Le Chatelier, who is the guy that Le Chatelier's principle is named after. Every system in chemical equilibrium under the influence of a change of any one of the factors of equilibrium undergoes a transformation that produces a change in the opposite direction of the factor in question. And a little later in this chapter, we'll be talking about Le Chatelier's principle, so I won't go into that right now. What do we mean by equilibrium? Well, we've been talking about kinetics, right? Kinetics studies how fast a reaction goes, whereas the extent of a reaction, how far it goes, is governed by thermodynamics. The equilibrium constant, K, is something that's quantitative and measurable that helps us to quantify how far does the reaction go. If we have a large equilibrium constant, that means that the reaction will favor the products. We'll end up with more products than reactants. A small equilibrium constant means the reaction favors the reactants. And this requires kind of a shift in thinking from Chem 1A, where we just sort of talked about chemical reactions as if they all just went forward until they ran out of something, right? We did limiting reactant problems, and we talked about, okay, well, it's going to go until this reactant is used up, and then the reaction stops. Well, that's not the case with many chemical reactions, and so that's what we're going to learn about. In a couple of weeks, in chapter 19, we're going to go into the thermodynamics and the reasons for the magnitude of the equilibrium constant. For now, we're just going to talk about the equilibrium constant. So the introduction here to the significance of equilibrium talks about hemoglobin. So your red blood cells contain a protein called hemoglobin, and that's just given the abbreviation HB. This is an illustration of hemoglobin. It's a very large, complicated molecule. Hemoglobin reacts with oxygen. Basically, it picks up and holds oxygen. Then your blood moves through your body, taking the hemoglobin and the oxygen with it. This chemical equation has a double-headed arrow, meaning that the reaction can occur in both ways. It's an equilibrium. The concentrations of reactants and products in that equilibrium reaction are described by the equilibrium constant. And equilibrium systems respond to changes in a way that maintain the equilibrium. So if we have a high concentration of oxygen, then the hemoglobin is going to pick it up and form this hemoglobin oxygen complex. If we go into an area where this equilibrium is disturbed because there's very little oxygen present, the reaction acts sort of like a stubborn child and says, I liked it how it was. You took away my oxygen. I'm going to do what I can to put oxygen back there. And so the reaction will move back this way to try to restore the oxygen concentration. Now, it cannot restore it completely to what it was before, but it will move in that direction. So this works out really well for our bodies. In the lungs, there's a relatively high oxygen concentration, and so the hemoglobin picks up the oxygen, and the reaction equilibrium shifts to the right, and we have a lot of this complex. As the blood goes through your body and comes to muscles that are low in oxygen, this is lower now, and the chemical equilibrium in my mind says, hey, I didn't like that, and so it's going to shift this way to release oxygen. So this is a very cool chemical reaction that allows our blood to take oxygen from our lungs and distribute it to the tissues that need oxygen. Any questions about that? How does an unborn baby get oxygen? So the unborn baby has its own circulatory system, and its blood does not mix with the mother's blood. So how does the oxygen get in there? Well, fetal hemoglobin has a larger equilibrium constant, so it's going to load oxygen at lower concentrations. So when the fetal blood and the maternal blood come close to each other, the oxygen can be transported from the maternal blood to the fetal blood. And the hemoglobin here will pick up the oxygen at a lower concentration and take it to the baby and distribute it there. So the fetus gets oxygen from the mother's blood, even though the blood doesn't mix. Pretty cool system.